Any deeper understanding of a particular subject demands that you should go back to the past. You should learn how these concepts came into being. You should learn what our ancestors did, what are the problems they faced, and today, whatever we are reading, we are learning, we are enjoying the science. These are being developed with a certain pace of time, with a certain sequence. This part of our video will concentrate on what is called a history, or rather the process of development of differential geometry. I know it is quite a long subject, it cannot be told just in a small video like this, but here is my humble attempt just to lay you down that what are the basic ideas and how differential geometry developed. Note to the viewers that there are much more than we can discuss, which is outside the scope of this video. Here is a small kind of a presentation on the developments of differential geometry.
Well, to give you an idea on the history of the development of differential geometry, we would have to rely on what we relied not only in terms of mathematics but also in terms of philosophy. We will go back to the days of the early Greek, when we found a person in the name of Eratosthenes is the first person who measured the circumference of Earth around 200 BC. We can call this will be the culmination and the starting point of measuring the circumference or any kind of a measurement related to Earth, and it planted the seed of differential geometry in terms of measurement. What we see next is obviously one of the great Greek pioneers, Euclid, in his book Elements, first carried the notion of measurement. Now, we have all read Euclid's during our school days, and the young people who are still reading Euclid's Elements is considered whatever we call as triangle, angle, length, measurements. Everything is there in Euclid's Elements, written in Greek language. It is the first and the foremost aspect in terms of defining measurement and creating a proper formal approach towards geometry. We call Euclidean geometry because we deal with notions and ideas which are written in Euclid's Elements. The first major attempt in order to find out differential geometry was made by this Flemish cartographer Gerardus Mercator. Now, Gerardus Mercator actually discovered something which is called a Mercator projection, and I am not going to give you more into Mercator projection, but the basic and the most significant contribution of Mercator was to develop a geographical chart or a map which is made out of our spherical globe of Earth. Now, it is Mercator who first perceived this notion that a spherical globe, or the measurement of the globe or Earth, can be flattened out into a two-dimensional map. It is also noteworthy that in 1569, Mercator published the first world map and coined the term Atlas. So Mercator, being a cartographer, made his first step and made a major contribution in differential geometry, although I would like to mention that Mercator knew about the pitfalls and the problems of this map design, which is flattening out a sphere into a flat surface, and was aware about the conformal nature of this projection. As we will go details into differential geometry, we will see that a sphere contains a positive curvature. It is impossible that you can flatten out a sphere into a flat Euclidean plane, which is a two-dimensional map and which has got absolutely zero curvature. Although Mercator knew about his limitation, yet his contribution is very significant. He developed what is called a geographical chart, and it helped during that time people out in the sea to make their navigation easily. In the middle stage, we come across this famous person, René Descartes, who introduced analytical geometry and which laid to the foundation of differential geometry in the further study. René Descartes, being a philosopher and a mathematician, also introduced Cartesian coordinates, and based on his analytical geometry, these three great personalities carried on further studies. Newton, Leibniz and Pierre de Fermat, they began the study of plane curves and inflections and circles of osculation. All these were based basically on Descartes' analytical geometry. So you see Newton, Leibniz and in further Fermat made important contributions in differential geometry in the study of the nature of the curves. Well, it is quite unusual in the history of mathematics that a single family has produced half a dozen outstanding mathematicians over a couple of generations. Yes, we are talking about the Bernoulli brothers, who has been quite important in contribution of differential geometry. The most outstanding three Bernoulli mathematicians, they were Jacob, Johann and Daniel. They were the three most influential experts in the academic community, yet they were very hostile to each other in terms of competition. They belonged to a prosperous family of traders and scholars coming from the city of Basel in Switzerland. Although Jacob and Johann developed a kind of a rather jealous nature of each of their brothers, yet they maintained a very competitive relationship. The family actually from Holland with a strong Calvinism religion came from Switzerland, and this is the Bernoulli brothers made significant contribution to the use of infinite symbols to study geometry. As we have seen that we have told that differential geometry is basically using calculus. So the Bernoulli brothers used calculus to calculate infinite symbols to the study of geometry. This particular book, which is called Analysis of the Infinitely Small to Understand Curvatures, is actually collated by another French mathematician called Guillaume L'Hôpital and later authored by Johann Bernoulli. It contains the tangents to plane curves of various types and which are computed using the condition dy equals to 0. Similar points of inflections are calculated. I would like to mention that Guillaume L'Hôpital is a French mathematician who first studied on the problem, what is the value of 0 upon 0? Is it infinity? Is it minus infinity? What it is? So it is basically called L'Hôpital's contribution, but later named into Johann Bernoulli's contribution. He and L'Hôpital and Johann Bernoulli, they studied a lot into the intrinsic curvature nature, and they studied, and it was finally put up into this book which L'Hôpital actually collated. So Bernoulli brothers, another very important figure in differential geometry. Okay, so we have got someone, Alexis Claude Clara, around our 1713 to 1765, a French mathematician who studied space curves and tangent and subtangent. He is the first one who introduced implicit understanding of tangent spaces. Now, you might ask a question that what is implicit understanding of geometry? We will let you know once we read Theorema Egregium by Carl Friedrich Gauss. But Alexis, he is basically a mathematician, astronomer and a geophysicist, introduced the concept of tangent and subtangent direction to space curves in relation to the direction which lie along a surface on which the space curve lies. He demonstrated the implicit understanding of the tangent space, and he is the first person to coin curvature, double curvature and principal curvatures, which were further extended by the prince of mathematics Carl Friedrich Gauss. Well, what can you tell about this great person? Leonhard Euler, being a student of Johann Bernoulli, first used the analytical geodesic equation. This is very important later in differential geometry as well as in the developments of Einstein's general theory of relativity. Euler was the first person to introduce analytical geodesic equation, and which he also introduced the concept of intrinsic geometry, and most importantly Euler-Lagrange equations is very, very important in terms of modern differential geometry. Well, Gaspar Monge around 1700 made important contributions in the theory of plane curves. Most importantly, this great French mathematician is basically the inventor of descriptive geometry. Okay, and he made important contribution in terms of reforming French education. He is one of the founder of the great institute, famous institute, École Polytechnique in France. Well, Gaspard Monge made contribution in theory of plane curves and surfaces and studied surfaces of revolution and envelopes of plane curves and space curves. So we see Gaspard Monge making very important contribution in terms of differential geometry. We have seen Euler, and we have seen earlier in terms of Pierre de Fermat and Alexis Claude Cloma, who are making important contributions, and we have already seen that the seed is planted. Usage of calculus in geometry.
The non-Euclidean geometry, which was actually started from the time of Lobachevsky, and it is called hyperbolic geometry, actually freed our notion of differential geometry. It started to free from coordinates. Now, I have taken a note which I would like to read out. Lobachevsky actually replaced Playfair's axiom with the statement that for one given point, there exists more than one line that can be extended through that point and run parallel to another line of which that point is not a part. So what happened is that with this kind of a statement, he developed the angle of parallelism. Right, the angle of parallelism, in which the depends on the distance of the point. Now, also I would like to tell you that in case of non-Euclid hyperbolic geometry, the triangles that we form are always less than 180 degrees. Now, you see, we have first come out of the notion that the angles of a triangle typically in Euclidean geometry is always 180 degrees. No, in hyperbolic geometry and further it changes. Sometimes it is less than 180 degree, sometimes it is more than 180 degree. So just to keep on the importance of the historical development, it is Nikolai Ivanovich Lobachevsky who is generally called the founder of hyperbolic geometry. This is the starting point of history when we started to think in terms of non-Euclidean geometry. So you saw a basic idea on the sequence of differential geometry, how it started with Eratosthenes and it went forward. But still we are stuck at one point. Who discovered the non-Euclidean geometry, or which point of our history triggered off the differential geometry? Here is a quick look.
Start digging the roots where from actually differential geometry started, or who are the people and what are their works in order to which triggers of differential geometry, we will be lost. Because each of the contributions, each of the mathematicians' contribution is very important in terms of differential geometry. We started with Eratosthenes and then we moved into Descartes and then Pierre de Fermat, Newton, Leibniz. Everybody's contribution is important. However, historians and mathematicians, when they talk about the advent of non-Euclidean geometry, the immediate person that comes to our mind is this: Nikolai Ivanovich Lobachevsky. Being a Russian mathematician born from 1792 to 1856, he is rightly considered by Kingston Clifford, the founder of Clifford algebra, as the Copernicus of geometry, because when we think of Copernicus, his entire foundations and his discoveries actually revolutionized astrophysics and astronomy. So Lobachevsky's contribution to geometry actually earned him the title the Copernicus of geometry. He is born in a moderate family and his father died around about 7 years of age when he along with his mother moved to Kazan district in Russia. He is actually mentored by Johann Christian Martin Bertels, who was a former, I would say, a student as well as a close associate of the famous Carl Friedrich Gauss. So he was being mentored by him. He is actually the founder of hyperbolic geometry, and he worked at Kazan University. He received a Master's of Science and Mathematics, and he actually, I would say, worked on Euclid's fifth postulate. Now, for years, mathematicians have been trying to deduce Euclid's postulate from other axioms, but Lobachevsky created a geometry in which the fifth postulate is not true. Right. So his geometry was based on the assumption that in the plane formed by a line and a point not on the line, it is possible to draw infinitely many lines to the point that are parallel to the origin. It was later proved that his geometry was self-consistent, and this actually triggered off differential geometry. As you will see that when we speak of lines, right, which actually can be drawn infinitely through that point and they are parallel to the origin, that is basically what replaces Playfair's axiom of Euclid's fifth postulate, and he created a new geometry. However, some mathematicians and historians wrongly claim that Lobachevsky in his studies of non-Euclidean geometry was influenced by Gauss or something like that. But the fact is that Gauss himself appreciated Lobachevsky's work. So it is a matter of debate. So we won't go into that kind of a discussion. But the debate remains open. But Gauss actually appreciated Lobachevsky's contribution to hyperbolic geometry. So Lobachevsky, along with an Hungarian mathematician János Bolyai and the famous Carl Friedrich Gauss, actually they founded what is called hyperbolic geometry. So these three eminent figures contributed towards hyperbolic geometry, and as we will see that this actually triggered off the very starting point of differential geometry.
Now these are actually the foundations of differential geometry. I mean to say the way differential geometry actually moved, starting from the Euclid's time, starting from Eratosthenes, and then we moved into Carl Gauss, Bernhard Riemann, and further. Now, but you have to note one thing, that we are still stuck with the classical era, right? I mean to say the basic notion of differential geometry till now what we saw is still we are stuck into the classical era. But what about the modern era? What about the developments in this century, what is happening right now? Here I present a very small, I know there are a lot of mathematicians and important people I have missed, but as you know, we have to make videos in a certain stipulated time. Here is one small snippet or a small presentation on who are and what are the recent developments and changes which are happening in modern differential geometry.
Well, the modern differential geometry emerged early in 1900 along with the foundation contribution of many mathematicians, and among them first we encounter Henri Poincaré on the foundations of topology around about 1900. So we see the contribution of Henri Poincaré's contribution in terms of topology first laid the foundation stone for differential geometry. Well, the notion of topological space, which we often call the Hausdorff space, is being first founded by Felix Hausdorff. He is considered one of the founders of modern topology. Hausdorff's father, Louis Hausdorff, was a Jewish merchant, and just to add more to this, I would like to tell you that Felix actually suffered a lot being of Jewish origin. From 1887 to 1891, he studied mathematics and astronomy in the Leipzig University, and in December 1901, Hausdorff was appointed as adjunct professor at the University of Leipzig. As a Jew, his position became very difficult. In 1941, he was scheduled to go to an internment camp, but somehow through some of his influential friends and colleagues, he managed to avoid. On the night of 25th of January 1942, both Hausdorff and his wife committed suicide, and they were dead by the 26th of Jan. However, the significance and contribution of Felix Hausdorff continues as the founder of topology and topological space. Élie Joseph Catton, an influential French mathematician who did fundamental work in the theory of Lie group and differential geometry. So you see, Élie Catton helped reformulate the foundations of the differential geometry of smooth manifolds in terms of exterior calculus. Well, if you want to know what is exterior calculus, it is a bit technical term. However, exterior calculus is a branch of differential geometry that generalizes the concept of differentiations to antisymmetric exterior derivative. It is generally called as a generalization of the fundamental theorem of calculus to Stokes' theorem. This gentleman, Jean-Louis Koszul, actually first introduced the concept of vector bundles. Vector bundles are topological constructs that makes precise the idea of family of vector spaces parametrized by another space. So first we started with Poincaré, then we moved to Felix Hausdorff, Elie Cartan and Jean-Louis Koszul, introducing the concept of vector bundles, laying the foundation of modern differential geometry. Xing-Shen Chern. Well, this person is considered to be the father of modern differential geometry and is widely regarded as a leader in terms of geometrical studies. Well, Xing-Shen Chern graduated from Nakai University in Tianjin in China around 1930. He got his MS degree in 1934 and he received his doctorate from Hamburg University, Germany in 1936. His fundamental contributions to differential geometry has been many. As you see that I have listed down few of his contributions which are highly technical to discuss: Chern-Class, Chern-Gauss-Bonnet theorem, Chern-Weil homomorphism and Chern-Simons invariance. The physics Nobel Prize winner C.N. Young once said that Chern is as par as with Euclid, Gauss, Riemann and Cartan. He worked for a long time in Institute for Advanced Studies at Princeton, and where he met Philip Griffith, the then president of IAS, who wrote, "More than any other mathematician, Xing-Shen Chern defined the subject of global differential geometry, a central area in contemporary mathematics. His work spanned almost 7 decades and he helped to shape large areas of modern mathematics." Well, to be very honest with you, I have read about Xing-Shen Chern and it is too technical, but you can consider that he has got a huge amount of contribution in terms of differential geometry, developing a Chern class, and his works actually goes from general theory of relativity to invariant theory to cohomology theory, fiber bundles, Sheff theory and whatnot. So definitely Xing-Shen Chern's contribution to modern differential geometry cannot be ignored, and he is rightly considered to be the father of modern differential geometry. His student Xing-Tung Yao, he is a student of Xing-Shen Chern and he was awarded Fields Medal for proving the Calabi-Yau conjecture. Now, if I talk of Xing-Tung Yao, yes, I read a news that he has been entangled with a controversy with Grigori Perelman. However, let us leave aside those controversies and let the world decide. 1949, he was born in China. He went for PhD at University of California in around 1969. There he read Journal of Differential Geometry and was deeply influenced by John Milner's paper on geometric group theory. Yeah, so John Milner's papers on geometric group theory actually created the first flame within Xing-Tung Yao to create and make his career in geometry. He received his PhD in 1971 under Xing-Shen Chern, and his most widely celebrated results are one, which is called boundary value problem for Monge-Ampere equation. Second would be the positive mass theorem, and we would be happy to tell that positive mass theorem is actually refers to a collection of fundamental result of general theory of relativity and differential geometry. It actually states that gravitational energy of an isolated system is non-negative. He also worked with Donaldson and Karen Uhlenbeck. I think you know about Karen Uhlenbeck, American mathematician. She won the Fields Medal also. So it is called the Donaldson-Uhlenbeck-Yau theorem. His contribution also to Calabi-Yau conjecture, topological theory of minimal surface, and he is also the founder director of several mathematical institutes. As you understand, he is rightly called as the right son of Xingchen Chern, because as per the master, he is the right disciple and is immensely contributed in terms of differential geometry. 1930, we come close to Sir William Valence Douglas Hodge, who is quite known for his Hodge theory. Now, if you ask me what is Hodge theory, this is not the right platform right now to decide. However, this is a very important contribution in terms of differential geometry, which we can definitely read it later. Next we come with another gentleman called Ernst Mann, and in 1950 he first introduced the theory of fiber bundles. Now again this would be a little bit technical in order to mention what is fiber bundle, but let us understand for this that Ernst Mann connections and fiber bundles are a very important connection in terms of differential geometry. Lastly, we'll come to a great personality, Sir Michael Francis Atiyah. Now, to be very honest with you, to tell more about Michael Atiyah, it would require more time. However, I would tell you that he won both the Fields Medal and Abel Prize. Particularly, Michael Atiyah is known for K-theory, Atiyah-Singer index theorem, which deals with further the instantons and monopoles, and Atiyah algebroid and Atiyah conjecture. Michael Atiyah, if you have read my, what I would say, interview with my professor Daksh Lohia, he encountered Sir Michael Atiyah in one of his discussion at Cambridge University, and he is a true genius. It would require a complete video of almost an hour to discuss about Francis Michael Atiyah, because his contributions are immense. And just to tell you, he also collaborated with three mathematicians. This person on your screen is called Raoul Bott, who is very famous for this Atiyah-Bott fixed point theorem. The next person would be Isidore M. Singer, who collaborated with Professor Atiyah to develop the Atiyah-Singer index theorem, which Michael Atiyah is mostly famous. And the last person is Friedrich Heisenberg, and he collaborated with Friedrich Heisenberg to develop what is called the topological K theory. So that is all. That is in short just to tell you who are the contributors, and we ended with a great person, Michael Francis Atiyah, whose contributions on the field of differential geometry is beyond, I would say, beyond comprehension. So we started with Poincaré and we ended with Michael Atiyah, and among them we saw the Hodge theory, we got fiber bundles, vector bundles, all definitely contributed to the development of differential geometry in terms of modern context.